Okay, now here we have a new chapter, chapter 6, and we'll be talking about sampling distribution. In chapter 4 and 5, we talk about probability distribution, right? So if we have a discrete random variable, then our probability distribution looks like we have been using a table, right? So we have a table here. Table consists of the values of x and the probability that x take those values. Okay, so let's say our x takes a value -1, 0, +1, and the probability that x takes a value -1, let's say this is 1/4. Probability that x takes a value 0 is 1/2, and the probability that x takes a value 1 is 1/4. So this is probability distribution for a discrete random variable. Okay, and we also talk about the probability distribution for a continuous random variable. And what did we use to describe or to represent our probability distribution for a continuous random variable? What did we use to describe the probability distribution for a continuous random variable? We use a graph, right? We use a smooth curve. So we have a smooth curve. Our curve can be a rectangular, or our curve can be a bell-shaped curve, or we might have a triangular curve. Okay, so we use a smooth curve to represent the probability distribution for the continuous random variable. And to find the probability that x takes some number between any two numbers is equivalent to finding the area under the curve, right? So if we have a continuous random variable, if you to find the probability is same as finding the area. We find the area under the curve. And if we have a discrete random variable, we have a table, and with the help of table we can find the probability. Okay, so we talk about this probability distribution. Now for each probability distribution, what we also calculated the mean of each distribution, right? So we calculated mu, which is the mean. And what is the next name for the mean of a probability distribution? Mean of a probability distribution, we call it expected value, right? So this mu is same as expected value of x. And we also had a sigma, standard deviation, for this probability distribution. Okay, and on the base on the mean and with the help of mean and a standard deviation of this probability distribution, we can describe about the probability distribution. Okay, so this is what we did in our chapter 4 and 5. Now, so we have a parameter here, and we know what is parameter. So we use the parameter to describe the or the numerical description of a population is parameter. Okay, so if we use any number to describe our population, we call it parameter. Okay, and since population is always large size, okay, it's really difficult to calculate the parameter. Okay, now the next, if we also use this parameter to describe the probability distribution, like here, so we have this discrete probability distribution for discrete random variable. We use mu, we use sigma to describe this table, and this mu sigma is also parameter. Okay, so parameter is a numerical values. We use that numerical values to describe our population. We use this number to describe the probability distribution. Okay, so mu sigma are the parameter. In the similar way, we have a statistic, sample statistic. Okay, and this sample statistic is the numerical descriptive measure of a sample. So if we are talking about a sample, and if we are finding a mean of a sample, standard deviation of a sample, then those mean, standard deviation are the statistic. Okay, and these sample statistic are calculated from the sample. Now here we have a table, the list of population parameter and corresponding sample statistics. So if we are interested in finding a mean for a population, then mu, we use mu to represent the mean of a population, and this mu is a parameter. Okay, if we are talking about the sample, the same mean is our statistic. So we have x bar for the sample mean. Okay, in the similar way, we have a eta for the median. If we are finding the median of a population, it is eta. If we are finding, or if we have a m for the median, then we use this m for the sample. Okay, sigma square, sigma p, these are the parameter. Okay, so mu, eta, sigma square, sigma p, these are the number. These are a single number. We use this number to describe our population. Okay, and this notation, mu, sigma, eta, sigma square, p are the population parameter. And we have a x bar, we have a m, s square, s, p hat. These are the number that describe our sample, and we call it a statistic. Okay, so if we have a number that describe population, that is a parameter, and if we have a number that describe sample, we call it a statistic. Okay, so statistic refer to a sample quantity, and the parameter refers to a population quantity. Okay, okay, do you have any question on here? So this is something what we had earlier. Okay, now, so like from the very beginning, the two major goal of this statistic class, do you recall what are our two major goal of this class? So what are we trying to learn here? So what are the two different type of statistics we have? We have a descriptive statistics and inferential statistics, right? So our very first goal is we try to gather the patterns in the data. We try to study the data. Okay, we learn the patterns on that data. So that is a descriptive statistics. So gathering the information about the data or learning the pattern of the data, that is one of our goals. And the next goal is inferential statistics. Inferential means we make an estimation, okay, or we make a generalization, or we make a decision with the help of sample about population. Okay, so making an estimation of a parameter or making a generalization for a population is our second goal. Okay, so these are the two things that we will be learning here. So in our very first three chapters, we learn about the descriptive statistics. Now here we will try to use our sample information to make an estimation of our population. Okay, now here we have two different sample. Okay, so this is an experiment of rolling a dice. Okay, so we have two dice, we roll it and we record the number that face up. So in a first sample, so we have 2 first, 2 second, and 6 third. Okay, and in the second sample we get 3, 4, and 6. So we are rolling a dice. Okay, so in first sample we have 2 again, and 6. So these are the upper face that we get. Okay, and we have a second sample, and in the second sample we have a 3, 4, and 6. So these are the upper face that we get when we roll a dice. Now for each sample, okay, so we have 2 samples. Now for this sample 1, we find the mean. Okay, so we can find the mean for this sample. And how do we find mean? We add all and divide by 3, right? So 2 plus 2, 4 plus 6, 10. 10 divided by 3 is 3.3. So our mean is somewhere here. We find the median for this sample, and our median is 2, right? Do you all agree with this? And our median is here. Okay. Now for the second sample, let's find the mean. So x bar is 3 plus 4, 7 plus 6, that's 13 divided by 3. Is that 4.3? So our mean is here. Let's find the median for this sample, and median is 4. So our median is here. Okay. Now we have these two samples, and our target is making an estimation of our parameter mu. Okay, so we are trying to estimate our population mean, which is the parameter. So this is our parameter mu from the sample mean, which is x bar or median. Now, so in sample 1, out of x bar and median, which one gives a good estimation of our mu? And our mu is somewhere here. Okay, so this should be 3.5. So our mu is 3.5. Now from sample 1, our mean of a sample 1 is 3.3, median of a sample 1 is 2. Now which out of mu, so out of x bar and median, which one is a good estimator of mu? X bar. Why x bar is a good estimator of mu? Our mu is 3.5. That's what we know. So why x bar is a good estimator for mu? It is close to mu, right? Our x bar is 3.3, and 3.3 is close to 3.5. Okay, so in sample 1, x bar is a good estimator. Now in sample 2, we have the same experiment, but we have a different sample. Now in sample 2, which statistic is a good estimator of mu here? Our x bar is 4.3, our median is 4. Now, and mu is still same, mu is 3.5 in this case. Okay, so mu is also 3.5. Now which statistic is good estimator? M, right? So median is a good estimator for mu. In a sample 1, we had mean. Now if we have a third sample, which one will be the good estimator? Now are these information enough for us to make a decision here? So according to sample 1, mean is a good estimator. It means we can use mean to estimate our population mean. From sample 2, we know that median is close to population mean. It means median is a good estimator for population mean. Okay, and if we have a third sample, then we might get median or mean. Okay, now here, now in each sample, so x bar, so we have a x bar 3.3 from sample 1. In sample 2, our x bar is 4.3. In sample 3, we might get a different number, right? So x bar is not the same. So what do we call here x bar then? Can we take our x bar as a variable? Now from here, since x bar does not have a same value for each sample, x bar is taking different values, means x bar is a variable. Okay, in the similar way, our m, okay, this is a statistic, m is also different for different sample, so m is also a variable here. So we have this statistic x bar, median as a, we can call it random variable. Okay, and since these are the random variable, to describe x bar, median, or to learn about their properties, we need a distribution. We need a probability distribution. Like here, if we go back to our chapter 4 and 5, so what are these x? So what are these x? These are the random variable, right? So this x is a discrete random variable. This x is a continuous random variable. Okay, and to study about this random variable, we have a probability distribution. So this table is a probability distribution for this continuous random variable. This is smooth graph is a probability distribution. In the similar way, now here we have a different sample. These statistics are a random variable. Okay, so x bar m, these are the random variable, and to find the probabilities, okay, or to learn more about this random variable, we need to define a probability distribution, and that distribution we call it sampling distribution. Now you have to be able to find the difference here. Now chapter 4 and 5 we had a probability distribution. Okay, we had a x. Okay, so in this probability distribution we make a list of the values x takes, like -1, 0, 1, and the table also consists of the probability for each x values. In the similar way, we have this continuous random variable and we have a smooth curve for the probability distribution. We find the area that gives us the probability. Now in this chapter we have statistics as a random variable. Okay, statistics means what are we talking about? We are talking about x bar, we are talking about m, okay, median, we are talking about s square, s, p hat. So these are our statistics. These are random variable. Okay, and if our table consists of the values for this random variable and their associated probabilities, we call it sampling distribution. Now if we have, okay, let's take two different example here. Okay, so here, okay, now we have three different probability distribution. Now out of these three probability distribution, which distribution is sampling distribution? How are we gonna know? So out of these three probability distribution, which are sampling distribution? So sampling distribution must have a statistic. Okay, your variable is a statistic, and statistic means your variable must be x bar or m, s square, s, or p hat. So if you find a table with x bar, m, those are sampling distribution. Okay, so here first table the variable is x, and we use x for the discrete random variable or continuous random variable, right? So this is our probability distribution. Now we have a table here, and x takes a number which we can make a list. So our x is a discrete random variable. Now in second table we have x bar. Our variable is x bar, and x bar is a statistic. Okay, these are the numbers that our statistic takes, and we have their probabilities. Okay, and what do we call this table? This table is sampling distribution. The first table is probability distribution for a discrete random variable. Second table is sampling distribution of x bar. Now third table we have m. M is statistic. Okay, and m, we have the values that m takes, like -5, 0, 5, and their probabilities. And this table is also sampling distribution. Okay, so if you find a table with a statistic, those tables are the sampling distribution. Okay, and if you have the table with a x variable, then it can be a probability distribution for a discrete random variable or a continuous random variable. Okay, so this is how we can identify our sampling distribution. Okay, now we have this smooth curve here. What kind of distribution is this? Is this the probability distribution or sampling distribution? How do we know it's sampling distribution? X bar, right? So we have the x bar. So we have this statistic. Okay, and we have this statistic, and from here we know this smooth curve is a sampling distribution. Okay. Now here we have a two sampling distribution. Okay, so we have a red smooth curve, which is the sampling distribution for our statistic B, and we have a purple smooth curve for a sampling distribution of statistic A. Now here statistic A, statistic B. So what are A and B? What are the possible values, or what are the possible options for A and B? A can be, what are A and B? A can be X bar, A can be median, A can be S square, it can be S or P hat. Okay, it's always statistic. So they use A for some statistic. Okay, they use B for other statistic. So it's always about X bar. It's always about M, S square, S or P hat. So we have these two different sampling distribution for two different statistics. Okay, so and we have sigma square. Now what is this sigma square? Is it parameter or statistic? It's a parameter, right? So we have these two sampling distribution for statistic B and statistic A, and we want to find the best sampling distribution to make a estimation of sigma square. Okay, so our target is making an estimation of parameter with the help of statistic. Okay, now we have a two different sampling distribution for two different statistics, and we want to pick one sampling distribution that describe or that can be used to make an estimation of sigma square. Now which one will be the best estimator here out of sampling distribution for statistic A or sampling distribution for statistic B? What do you think? Which one will be the best? So we have to look for two things. Okay, we always look for the sampling distribution that is centered over parameter. Okay, now out of these A and B, which sampling distribution is more centered over parameter sigma square? A, right? Okay, our purple curve is more centered toward our parameter. And the next thing, we look for the sampling distribution that has a less variability. Now, out of A and B, which sampling distribution has a less variability? Variability means less spread. Which distribution is less spread? A, right? So our statistic A will be the best estimator for our sigma square. Okay, two things. You always look for the sampling distribution that is centered at the parameter. Okay, you always pick a distribution which is centered at the parameter. And the next, we always pick a sampling distribution whose variability or whose standard deviation is less. Okay, so out of this statistic A and B, we pick sampling distribution for statistic A to make a estimation of sigma square. Any question? Two things. Okay, you have to check for the whether your sampling distribution is centered at the parameter or not, and the next thing, whether your sampling distribution is less variable or not. And if these two things are satisfied, then you're gonna pick that sampling distribution to make an estimation. Okay, now before this example, now so we have here histogram. Now, what kind of distribution is this? Is it a probability distribution or sampling distribution? What do you think? Sampling distribution. Now here we have a X bar, right? This is a statistic. We have a median. Now out of this, so we have a two different sampling distribution. Okay, so we have a sampling distribution for X bar. We have a sampling distribution for median. Now out of these two sampling distribution, which sampling distribution would be a good estimator for our parameter mu? X bar or median? It's going to be a X bar, right? So our X bar, so the sampling distribution for X bar is more centered towards our mu. Okay, so okay, it should give. Okay, let me check if we have a mu here or not. The mu should be. Okay, mu is 175. Okay, that's given to us. So here mu is 175. So 74, 70, this is our mu. Okay, 74, so let's say somewhere here, okay? And from our first sampling distribution, our sampling distribution is more centers toward our 175. And the next thing, which one has a less variability, or which one has a less standard deviation? Sampling distribution for X bar, right? The first histogram has a less spread. It means it has a less standard deviation. So we pick the sampling distribution of X bar to make an estimation of this mu. Okay. Now here we know what is mu. Okay, it gives us so that we can make a comparison here. But we don't get, we won't have any idea of mu. If we know mu, there is no point of making an estimation, right? So in this case, it's given to us. But in most of the case, parameter will be unknown, and we have to use the sampling distribution to estimate our parameter. Okay. The next thing we have to, now here in example 1, we learn how to create a sampling distribution. So here in a single toss of a fair coin, let X equal the number of heads observed. Okay, so we have X equals to the number of head observed. Now consider a sample of N equals to 2 tosses. So we have a fair coin, and our X represents the number of heads observed, and we toss a coin for, we have a 2 toss, okay? Find the sampling distribution of X bar. So we have to find the sampling distribution of X bar, which is the sample mean. Okay, so here, now let's make a table. Now we have an experiment of tossing a coin, right? We are tossing a coin for, we have a 2 tosses. Now what are the outcomes here? Now let's make a list of outcomes here for this experiment. When we toss a coin, or when we have a 2 toss, what are the outcomes we will get? Okay, we might get head, head, right? We might get head, head. We might get head, tail, or tail, head, tail, tail. Okay? And now for each outcome, let's give the value of X. How we define our X? X being the number of head observed, right? So in the, let's say in the first toss we have head, we get head. Now if that is the case, what will be value of our X in the first toss? It will be 1. Do you all agree? Our X is the number of heads observed. Okay, so in the first toss our X is equals to 1. So in the second toss, what is X equals to? It's still 1, right? Because we have head. Now for the second outcome, what will be the X for the first toss? 1, because we have a head. And the value of X for the second toss is? We get tail, means we don't get any head, that is 0. So in the third outcome, we have a tail or a head. So the value of X in the first toss is 0. The value of X in the second toss is 1. For the outcome tail, tail, the X value for the first toss is 0. The X value for the second toss is 0. Now, does anyone have question here? So we have the experiment of tossing a coin. Okay, we make our 2 tosses. Now, and the next thing we write down, or we give the value of X on each toss, and we define our X to be a number of head observed. Okay. Now the next, we are asked to find the sampling distribution of X bar. So let's find the X bar here. So for each outcome, what will be X bar? So for the first outcome, our X is 1 and another X is 1. So what will be X bar? It's a mean. We are finding the mean. So we have 1 and 1. What is the mean? 1 plus 1 divided by 2 is 1, right? 1. So for the x value 1 and 0, what will be the x bar? 1 half, right? So for the x value 0 and 1, you find the mean, so which is 1 half. For the x value 0 and 0, we find the mean, which is 0. Now, why are we calculating mean here? Why not median? We are asked to find the sampling distribution of mean. So here, we are asked to find the sampling distribution of mean. So we are finding a mean for each outcome. Okay, mean of x values for each outcome. If it was median, then we find the median of each value, median of x values for each outcome. Okay. Now the next we need to find. So what is the probability here? Okay, let's find the probability of each outcome. So what is the probability of getting head? 1/4. Okay. What is the probability of getting head tail? 1/4. What is the probability of getting tail head? 1/4. And what is the probability of getting tail? 1/4. Do you all agree? Now let's find probability of x bar. Okay, now we are trying to create a sampling distribution. So sampling distribution means we need to create a table. Okay, we need to create a table, and that table will have the values of x bar. We are not using x, we are using x bar. Okay, we are creating sampling distribution, so we must have a statistic. Our statistic is x bar. Now what are the values for x bar? 1, right, so you can start from, like, if you want to write 0 false, it's okay, or 1. So x bar is 1, right? Our x bar is 1/2 and our x bar is 0. So x bar takes a value 1, 1/2, 0. The next here we need to find the probability that x bar takes this number. Now what is the probability that x bar is equals to 1? What is the probability that x bar is equals to 1? Is it 1/4, right? See, so probability of getting head is 1/4. Okay, and we have x bar 1 here, so it's the same. So the probability that x bar takes a value 1 is 1/4. In the similar way, what is the probability that x bar takes a value 0? 1/4. Now what is the probability that x bar takes a value 1/2? Now it's 1/2. Now how we know that it's 1/2? So we are trying to find probability. We are trying to find probability that x bar takes a value 1/2, right? Now what are the outcomes here that has x bar 1/2? Head, tail, head, right? So we are interested in finding probability of getting head, tail, or tail, head. Okay, so this is OR, union. So we add a probability of head, tail, and probability of tail, head. So probability of getting head, tail is 1/4 plus probability of getting tail, head is 1/4. This is 2/4, which is 1/2. So we have 1/2. Now our table is complete. And this table is our sampling distribution of x. So this is sampling distribution of x bar. So this is the sampling distribution of x bar. Now, does this sampling distribution meet the two properties of a probability distribution? So the first property is that is the value of x bar. Okay. So what is the first probability? Is it has to be greater than equals to 0? Okay, now here, so the first property is that is the probability that x bar takes some number is greater than or equals to 0. The probability, like the probability that x bar is equals to 1, which is 1/4, right? The probability that x bar is 1/2, which is 1/2. The probability that x bar is 0, which is 1/4. So the probability that x bar takes some number is always greater than or equals to 0, right? So this is the first property. The next property is the total probability equals to 1. Now if you add probability that x bar takes number 1, 1/2, 0, the sum is equals to 1. Is it true? So if we add all this probability, sum has to be equals to 1. Okay, so it does meet the two properties. So this is our sampling distribution of x bar. Okay. Okay, do you have any question here? Okay. Now, okay, so for this example, so we just compare which sampling distribution is a best estimator. Okay, we will not be finding the table here. Now we have an activity for this section, so I want you to go to that activity, and here, so we have this first table. And what is this first table? Is it a sampling distribution or probability distribution? It's a probability distribution of what kind of variable is x here? It's a discrete, right? We can make a list for x values 1, 2, 3, 4, 5. So this is our probability distribution. Okay. And so this x is observed twice. If these observations are independent, verify that the different samples of size 2 and their probabilities are as follows. So this is given. So it means our x variable, so this x variable is observed twice. So at first you observe 1, you observe 1 here. Okay. And observing 1 first, 1 second is 0.04. Okay, so we have 2, 4 means you observe 2 first and we observe 4 second, and that probability of observing 2 first, 4 second is 0.06. Okay, in the similar way, like 5, 3, so it means we observe 5 first, then we observe 3 second, and the probability of observing 5 first, 3 second is 0.02. Okay, that's what we are given to us. Now our target here is find the sampling distribution of a sample mean x bar. Okay, so we have to create a table very similar to one we just had. Okay, so to create this sampling distribution we need a x bar. Okay, now it's easy, right? So let me add here. So we have a x bar. So what will be the x bar for the values of x, 1 and 1? So 1 plus 1 divided by 2. So we are finding the mean. Okay, you are finding the mean for this each sample. So this is your first sample, this is your second sample. So we have a list of sample and we have their probabilities. So first we find the mean of each sample. So we have 1, 1. So to find the mean, 1 plus 1 divided by 2. So that is 1, right? So we have 1 and 2. 1 plus 2, 3. 3 divided by 2 is 1.5. 1 plus 3, 4. 4 divided by 2. Is it always dividing by 2 or only in this example? It's only in this example, right? So we all know how to find the mean, right? Okay, so 1 plus 4, 5. 5 divided by 2 is 2.5. 1 plus 5, 6 divided by 2, 3. 2 plus 1, 3. 3 divided by 2, 1.5. 2 plus 2, 4 divided by 2, 2. 2 plus 3, 5 divided by 2, 2.5. 2 plus 4, 6 divided by 2, 3. 2, 5, 7 divided by 2, 3.5. 3 plus 1, 4 divided by 2, 2. 3 plus 2, 5 divided by 2, 2.5. 3 plus 3, 6 divided by 2, 3. 3 plus 4, 7 divided by 2. So we have x bar for this sample, which is 3.5. 3 plus 5, 8 divided by 2, 4. 4 plus 1, 5 divided by 2, 2.5. 4 plus 2, 6 divided by 2, 3. 4 plus 3, 7 divided by 3, 3.5. 4 plus 4, 8 divided by 2, 4. 4 plus 5, 9 divided by 2, 4.5. 5 plus 1, 6 divided by 2, 3. 5 plus 2, 7 divided by 2, 5.3. 5 plus 3, 8 divided by 2, 4. 5 plus 4, 9 divided by 2, 4.5. This is 5. So we find the mean for each sample. Okay. Now creating a sampling distribution means we are making a table. So let's go ahead and make a table. And what do we have on our table? We have the values that X bar takes. So we have a X bar and the probability of that X bar. Now what are the values our X bar takes here? So it takes 1, right? It takes 1.5. Does it take 2?
It doesn't. It takes 1.5.
Oh, 1.5?
And then 1.5.
Where is 1 and oh,
1/2.
where is that? Okay, I missed that 1/2.
1 is, oh, sorry.
1 plus 1 is 2 and divided by 2 is, I think 1 is, right?
Yes, you're right.
Okay. The next is 1.5. We have 2. The next we have 2.5. We have 3. 3.5. Okay, we do have 4. We do have 4.5 and we have 5. Oh, I'm sorry. Now, any question for this part? You find the mean for each sample, then you make a, without repeating, you make a list of X bar. Now, we find the probability that our X bar is 1. Now, let's find out how many times our X bar is 1. So, how many times do we have? 1 time, right? So, this is the only case where our X bar is 1. And what is the corresponding probability for this? 0.04. So, 0.04. 0.04. Now, we find the probability that X bar takes 1.5. Now, how many times, or okay, let's see, where do we find X bar 1.5? So, here we have 1.5. Do we have any more? Okay, we have 1.5 here. Any more? No, right? So, we are asked to find probability that X bar is this 1.5 or this 1.5. Okay, it's OR, so it's union. So, we are adding 0.06 and 0.06. What is that equals to? 0.12. Good. Now, in the similar way, let's find the probability that X bar takes a value 2. Now, let's see how many times. So, we have X2 here. Okay, so here, okay, we have here 3. We have, yeah. So, you add these probabilities. So, you add 0.04 plus 0.09 plus 0.04. That is 0.08 plus 0.09. Is it 0.17? 0.17. Now, I want you to complete the remaining part here. Okay? Okay, number B, construct a probability histogram. Once you have the distribution, you know how to construct a histogram, right? You have the horizontal axis for the X bar and use P of X bar for the height of for its probability. And what is the probability that X bar is 4.5 or larger? I think you should be able to do this one. So let's do this much, and if you can't complete this one, we'll do it tomorrow, okay?